So please let me interview you about full self-driving.
All right, I'll do an interview. It's got to be on Twitter, but sure. All right.
Well, congratulations, John. Elon said yes. And based on the applause, I think the shareholders also said yes and are looking forward to this interview with Elon on FSD. So congratulations.
I'm over the moon, man. Hey, y'all, it's Dr. Know-It-All. As Scott was so kind to point out with his little video clip, I am very, very excited about the potential to do an interview with Elon Musk. So let's hope it actually comes about. I don't know. We'll see. It'll happen when it happens. And in the meantime, please forgive my voice because it was a long day and a long night. So very, very scratchy voice.
Yeah, a little bit.
I think my wife called it on Discord last night, right? She said, I'll have a scratchy voice for multiple days. So I do. So anyway, thank you so much for being with us again, Scott. And we are going to talk about Optimus. And yeah, so let's just take it away. There was a whole new video that apparently the AI or whatever, the Optimus team stayed up all night working on the night before. So
right. But before we get to that, I mean, the first impression was that I think this set the tone for the meeting.
Yes.
This was definitely set the tone for the meeting. And as soon as I saw that, I said, aha. Because we were speculating, it's shareholder meetings. Usually there's certain things you talk about, don't tell how much are they going to talk about Optimus or anything like that, just in passing. Are they really going to show or reveal anything? It wasn't a big surprise that they didn't reveal a new product because they've already said there's going to be a proper product unveiling. So they would hint at it, nothing else. So we weren't sure if we could get anything Optimus, but as soon as I saw the shirt, I go, aha, something is going on here. And the reason is because if we look at past meetings, important meetings, so this here is the shareholder meeting 1 year ago, all black t-shirt. This is going just back to February when they have the investor day. Again, a neutral t-shirt. So the shareholder meeting should be a neutral event. When he's at the AI days, he's wearing something that's AI related, of course, because it makes sense. Or battery day, there's a bet. But this time, what did he choose? And I think someone said it's because the Occupy Mars t-shirt was in the laundry. I don't think so. I think there was an actual reason behind it. And of course, my stated reason was that, it's about the bot, and if you couldn't tell from the start, you could tell at the end because the meeting pretty much before the questions period started, ended with Optimus. And of course, your take was a little bit different than mine. It's also about FSD.
Yes. Well, but again, I only think it's about FSD as it relates to driving the bot. So I don't know if we need to rename it. It needs to be renamed from FSD because it's not really full self-driving anymore. It's like full self-robotics or something. Yeah, exactly. I think there's going to have to be some sort of rebranding on that. So maybe we can get the German government involved in that. They can come up with good suggestions since they don't like autopilot. Like they can pick it. The Germans can pick out the name. Then it'll be about 30 or 40 characters long and all one word. So
yeah, exactly. And I'm waiting for the Autobahn to have full self-driving because it's in the name.
That's true. There you go. All right. So yes, indeed. So so I think the highlight of the show, certainly one of the highlights was the Optimus video that was played. That was fantastic.
And we'll show the whole clip right now.
Okay.
Without any commentary, so everyone can see it. It's 1 minute and 6 seconds, which, as you know, we're going to turn it into about 3 hours right now.
Right.
But we'll look at that and then we'll do the commentary. Okay, so we're back. And so now what I'm going to plan on doing is I'm going to go ahead and bring up my little viewer here. And of course, there's the very beginning, as we can see, John being interviewed. And let me go ahead and move our viewer here up a little bit. And so here is the Teslabot video. So of course, the very first thing we see is the Teslabot just walking. So we see it walking a little bit better. It doesn't tell us too much right now, except that it looks a bit more confident. And now this is the first thing where my heart really started to go. It's like, oh, there's more than one.
Yeah.
And they're walking together. Now, there's only 3 walking here. The other 2 are kind of sitting in the background, not doing much right now, but it looks like they're getting ready for something. Right. And this is quite an interesting one because now we can sort of see it out on the floor. Now, this isn't production. This is probably where they're doing a little bit of service on the vehicles that are there. It's probably somewhere in Fremont. We can see a bunch of different ones. But my take on this was, look at the technician right there.
Right.
He's like, look, I got a job to do. I don't have time for this, guys. Just, the bots again, they're coming through. So you kind of look at that. He's very kind of nonchalant, just going about his business while they're getting ready to set this thing up. And so we can see there's a couple moving around getting ready.
So actually, wait, if you want to pause on that for a sec, Scott, I think one interesting aspect of this is that you have talked a lot about cobots and how in order to have OSHA compliance and all sorts of other things, there's a lot of safety protocols, and it's really fascinating to me that there's an actual guy there, working within close proximity to these Teslabots that are walking.
Nothing to do with the bots at all, right? He's like, he's going in there, he's trying to fix something on the Cybertruck, and right here we see 1, 2, Cybertrucks right next to each other. So they're kind of leading up to something. So at this point, it's a nice little intro to give us a taste of what we're about to see. Right. And the next part here is the motor torque control. And I'll try to kind of play that through a little bit as we see it there. And you can see it's, it was showing a couple of things. One is that, I'm not sure if that's more like a jumping action or just being pulled up. So you can sort of see it has enough force to do that. The most important thing is that when it's coming down, it's able to suddenly sense that it's on the ground, and then the leg will deform to meet that. Of course, the question is how much force is being applied at that tip? Yeah. And how quickly is it able to react to that? So this is the proof right here is coming on down, and you see it's not breaking the egg. And of course, you want to know, is that a hard-boiled egg? And it's not. Right. Now, maybe he's got really good sleight of hand there. I look really close. We can ask a professional magician. I don't think he slipped in remove the hard-boiled egg and put in a raw egg right there. Well, Elon did say they were up all night working on this. So unless they have a very talented magician working on their crew, they probably didn't have time to do that. Exactly. Now, was the egg cracked? It probably was, but it wasn't smashed. I mean, you can't stop instantaneously, but boy, that is really quick. Yes. And so it tells me there's a lot going on there as far as the motion control, which goes just beyond that. Oh, that's really going to be good for walking. So it probably says something about we need to make sure that when the foot strikes the floor or the ground, that we're able to instantly kind of react to that and not have like the shock going through the body that you suddenly hit something. Because we're not quite sure how much compliance they have with the feet yet. Because that's the one thing we've sort of noticed about the bots as you go through. What we were seeing is that they're still flat-footed. These are not, they're not doing toe-offs for sure. So. Yeah, they're not doing toe-offs for sure. And also, it's very flat feet. I mean, they're not shoes. There's nothing springy in there. Not quite sure why, but that's going to be the next step is for them to get the toe-offs. But here, because the control system that they have, and I wonder how much of it is based on a neural network and it being able to sense that, sudden change in the environment. That there's nothing, and now suddenly have something, and now I have to react to it really quickly. Right. That bodes well for what's going on the hand. Yes. So a lot of people looking at this and thinking the leg and walking. I'm looking at the thing. I'm thinking the fingers. I think whatever they're doing here has a lot about grasping things and knowing exactly what the force is going to be to close something and what it feels like. So for me, that was something I really wanted to see, even if it had nothing to do with the hand. Oh man, that's so impressive, though. It is. It is impressive that you're not breaking that egg. Now, here it's of course just showing that finally Optimus is outside, going about the campus. Obviously, you'll probably have some comments here because we can see there's some sort of mapping of the environment.
I want to pause on the word, not discovery, but memorization.
Memorization, right?
This is going to actually impact full self-driving hugely if they backfill this into FSD, where it can memorize your neighborhood, your local environment. That is crucial stuff.
Right, man. What we're seeing.
Yeah.
Now, the first thing is that, after seeing this here, I tried to be as nerdy as possible. The first thing I was kind of wondering is, like, are they making some statement about bipedal robots in wheeled vehicles? It's almost like, I'm good. I don't need wheels. I'm able to get by. Now, this is a 4-second clip.
That goes back to our Boston Dynamics handle. Sorry.
Yes. Yep. And now this is a 4-second clip.
Right.
I'm starting to walk in, and I tried to estimate how much ground was covered. And I'm estimating maybe around 4 feet or something like that. So it's going about 1 foot a second, which is a little over a half a mile per hour. So it's not very fast. They still have a lot to go. It's not 3 miles per hour or 5 miles an hour fast. So 5 is the max speed, because you should be able to run away or actually briskly walk away.
Right.
3 miles per hour is more of the goal for what it really needs to be productive in the environment, because that's typically what an operator or any factory worker is going to be walking about that speed. Because 3 miles per hour, if you go out and actually measure yourself, something like that, and go for a walk, it's like, you're actually putting a little bit of effort. 4 miles per hour requires a lot. 5 is almost a jog. So yes, there's some room to go there. There's like a 4 to 6x improvement we need to have, because I'm saying it's roughly half a mile.
Thank you for doing that calculation. That's actually really interesting to figure that out. So
it's pretty tough to measure there. I was really trying to estimate everything by the length of the foot and looking where the steps were and all that. And someone else might be able to come back with a different estimate. So that's one idea that we have there is what the speed's going to be. And then, of course, looking at the environment, and evidently that must be in its head. So is that telling us it's walked that much, or where is all that data coming from?
Yeah. Well, and the cool part is, like, if you go back to that means that campus, the area, I assume this is the Palo Alto campus, that it has walked around that, and it now knows where that stuff is. And so, as opposed to, if you think about full self-driving, where you have a Google Maps that's already, grossly mapped out the environment, so you know where you are. It doesn't have that advantage, so it really does have to figure it out itself.
Yeah, and I'm assuming these are nerfs that are being generated.
Yes, some sort of
going around building it up.
Yeah,
and it looks like it's more kind of a ground level map.
Right.
You don't see any tall buildings or anything like that, so it's pretty much whatever in its field of view. It's not mapping anything up much higher because it hasn't been able to discover that yet.
Right.
Now, this next one is rather interesting. We saw something like this at AI Day, where they were showing that they had a VR setup to be able to go ahead and sort of teach the virtual bot. And so this is an interesting configuration that I'm going to ask you a few questions about. I mean, first, it was pointed out on your Discord that it's a rather interesting motion capture. So it looks like there's a certain special outfit that's being worn here.
Right.
And we can definitely tell that there's like hand controllers there to be able to do the finger motion. And I was wondering, well, how much are they using something like Connect, where they're just sort of looking at the body itself and figuring out what's going on?
Right. My guess would be looking at a more...
And then the headgear, which I'm going to come back to you on that.
Right. I think we're looking at a more traditional motion capture suit, probably using IMUs, inertial measurement units, or something like that. So, and a big backpack.
Well, that's what I'm wondering. This is a big backpack. I mean, what's going on with that backpack?
It's crazy.
Yeah. Okay. So there's this traditional motion capture. The first thing, this is the first thing I noticed, because these are the things that I notice all the time.
Yeah.
And that they haven't modeled the kinematics of the drive units back here. So you'll see that this is kind of broken from the drive unit.
Right.
It's easy to fix, and it's probably just not important to what they're trying to accomplish here. So that's more or less just getting a certain degree of perfection there that only someone like me would obsess about. But the main thing is we're seeing that the motion of the fingers is able to translate to the motions of the fingers over here, which is then being used to teach these grasp routines. Now, the few things to notice is that there's a certain amount of mapping you have to do between the human operator and Optimus. And there's not going to be one-to-one, because it's going to be really hard to find a person who's exactly the same size as Optimus.
Right.
So there's some sort of mapping. And some things are not quite perfect. So, for example, we know Optimus cannot move its head.
Yes.
It can only move its torso. So all the head movement has to be done like that. The human operator there is trying his best to not move his head, but he does occasionally. And we can sort of see right now his head is turning the wrong way, yet Optimus is sort of pointed that way. This arm here, his arm seems to be a little bit higher than what Optimus is. It doesn't really matter. All that probably matters is that the wrist is in the same world location as the operator.
Right.
The other thing to notice is he does not move his feet. He's keeping his feet planted. And I'd actually say the foot plant is a little bit different. He has a much wider stance in here, but the feet are not moving. But we can see that Optimus, we're getting a lot of movement in the hips to be able to accomplish that task.
Yeah, I mean, it looks like the suit itself may only be capturing his torso and above movement, so it may not even.
Yeah, it's hard to say what's being captured and what's not being captured there.
Right.
Now, okay, so we go to there, and this next one.
What were you going to say about the headset? By the by.
Oh yeah, let's go back to the headset.
Do you think that this gives him the view of the Optimus view of like what Optimus would see?
Yeah.
Okay.
But my conjecture is, all right, how many cameras does Optimus have? We've been talking about this.
Right, because we got the 2 on the side, the 2 that are down looking, and then it looks like maybe 3 forward. It's a little hard to tell.
It's hard to tell whether that's. I'd say there's at least 2 cameras there. I don't know if there's a wide field of view like there would be on the FSD.
That could be an IR like light. Like it could be shining a light on things. So if it's very dark.
But this camera seems to be kind of looking down because Optimus has to see down, and we can see that as. And I guess I should actually call him the sensei, because that's what I kind of think that is to be more is that the field of view is able to sort of see what's going on, and he can't really like tuck his head down because that's just not allowed. Optimus can't do it. So somehow you have to be able to get that. So you must have a similar field of view that Optimus has.
Gotcha.
And so that's why my guess is that there probably are 2, there's this a down-looking set of cameras that we've been speculating might be there.
Right.
And because we can't see anything in there now. Okay, this one here. There's a little bit of a backstory to this. It turns out. So the first thing to notice. The reaction.
So happy about that. Yeah.
The reaction. Okay.
Yeah.
This was tweeted out yesterday, right after the video from Julian Eberts, who is a staff engineer at Teslabot. Okay. And so he talks about that Optimus performed its first end-to-end learn successful grasp today.
Right.
You can see it below at 1K speed. Now, at 1x speed. Now, I think we know when that moment was. When you see this, it's like, whoa, it finally worked. Now,
it worked.
Of course, it was learned from human demonstrations. No task-specific programming was done. This means we can now scale quickly to many tasks. So up till now, I mean, at first I look, it's like, what? That's the first time Optimus picked up something. Like, come on, we've seen all these videos doing it. Yeah, but that was hand-coded, pretty much like what we've talked about with Boston Dynamics. We're kind of going through and getting everything. And they probably had these routines for like, close grasp or release or something like that. But still, a lot of it was very much handcrafted heuristics. And at this point, they're just saying, let's teach it how to grab a bunch of different things and let's see how it goes. So that there probably was the moment that happened.
Right.
And that's the background. That's why I splice that in there, is that's a very important point right there. Like, yes,
that's
went ahead.
What is he picking up, by the way?
Taught from here.
I really can't tell what he's picking up.
It looks like a lemon to me, but I could be wrong.
Okay. But yeah, it's just beautiful too. It's a really lovely grasping motion.
Yeah, finally did it. Now, the other thing that's sort of funny that people may not have noticed is he's a little bit bigger here. Is that
he's tethered.
Yes, but you see how he's tethered
with some nice carabiners and
in the head, John. In the head, there's nothing between Optimus's ears. Okay, the brains are in the torso, so you kind of look at that, and that's why that head plate is missing a lot. So you'll see a lot of images without that, which is rather interesting to see. So that's one little point to bring out. But now we can start to see the complexity with the different kinds of tasks that are going on here. And if we look at this task here, they're picking up something which is very flexible. So you notice how that thing deforms?
Ooh, nice.
So that is something that they're trying to teach it. All right, how to pick up something which is going to deform.
Oh, look at that. I mean, the
versus
putting away
something.
stuff, this is all like so nice.
Yes. Now, if you look here, it's rather interesting. They still haven't quite figured out the wiring for the wrist.
Right.
You know, I'm seeing this thing kind of poking up there. They still have a lot of cabling and everything else. So they're still
And
trying
he's also got
figure that
two.
out.
He's got two different iterations of the hands. One's gray,
Yes,
and black. So yeah.
yeah. So there's definitely a lot of different iterations of all sorts of things going on here. But yeah, that's sort of some beautiful movement there. Right. And then of course we have here where again we can see they've all they almost look like they've had lobotomies or something because you know.
Is it what's the? It was the Hannibal Lecter one, the second one where he like actually cuts Ray Liotta's head off or does scalp off.
Yeah. So so you kind of look at that. It reminds me a little bit of Skipper from the Penguins, you know, of Madagascar.
Yes, exactly.
Now here we've got the line dance going on to finish everything off. I assume Warren Redlick is off to the side coaching them on proper line dancing.
Right.
And of course, a lot of people, the first thing they notice is like, wow, look, we have 5 Optimi in one picture, in one image. But what else is in the same image?
And 3 Cybertrucks.
Three Cybertrucks. So the first, that's a first, it's a double first. I don't think we've ever seen 3 Cybertrucks in one picture before. So it could be that there's more because if you look at where that technician was working, I'm assuming it was all happening on the same time. There could be a couple more in some other bays, but confirm this. We can say, I suspect there's more than 5 Optimi out there because I think some of them were down here and some of them in other places. And even if we go back to this image here, we see there's like one back there. Now, whether these are the ones that are down doing the line dancing or not, it's sort of hard to tell. I was able to do a close-up right down in there. You could almost read a serial number on there. Almost.
Really?
Yeah. So that might be something they have on there, but it's too grainy to blow up. But you'll notice whatever label they have on there is a black label, and some of the others you'll see. I think in this one here, you'll see kind of a white label up right on down there or whatever it is. So
yeah.
If we can get down to that, you know, someone with like a really good AI enhancement kind of thing can go in and start reading those things.
We need to zoom and enhance.
Yeah, we can go in and we can tell it just like we can do with all the serial numbers on the boosters at SpaceX. You know, we can start doing it with the Optimi to come up. But so I can't quite tell.
If you go back to the line dance picture, they are all missing their scalps. And I could maybe not that image, but anyway, it was right like here. What they've done is they figured out that's a really good place to tether them because it's center of mass. And so what they did was they had them all tethered, and then they popped the tethers off and they filmed the shot, and then they put
exactly. So that's probably how they bring them out. Yep, for sure. Yep. Now you can see some variations here. Is that if you notice right here, these turtlenecks are kind of two-tone on this one and this one, but not that one. So it's either design iterations or it's one way to tell them apart. This guy here is the leader.
Okay.
And he's a leader because he's the only one with the belt buckle.
Oh, yeah, you're
the others do not have the belt buckle.
Yeah.
And you can also notice, I mean, the reason why my eye honed in there is I noticed that these motors here are kind of more of a silvery color, whereas these are black. So this is probably like the original generation, and now these are the next generation that you have here. So actually, and if you look really closely, you'll see that the wiring is a little bit different. So if you compare this one's wiring and that one, there's just like always a little difference.
Right. They're obviously still tweaking. So
yes, lots and lots of tweaking. And again, we can see what the feet are like is that just not getting that toe off like we'd like to see, but they're getting a bit more of the hip motion that we'd like to see. So the pelvic unlock when they are walking, we were able to see.
It's certainly substantially smoother than it was. That's for sure.
Yes, much better. So that is very important to people to do that with walking, and a little bit faster. I'd say before it was way more cautious in that movement. It seemed like it's really plodding. So it's probably at least a 2x from what we saw in February. But the main thing is like a bit more confidence. And what is the importance of the pelvic unlock?
Well, I mean, that's where that we've talked about that before. That's where
we sort of talked about it, is that if I don't have that as my legs go forward,
Right.
I do this with my body,
Yeah.
which means everything is kind of going back and forth. And,
Right.
and the reason you do it is to compensate for the twisting motion that the legs are putting in your body. So I can walk, and as I walk, my chest always remains in the same orientation.
Yes.
So that's rather important. So you just don't have that kind of going back.
Well, and
back
if you look at it too, it's not just the twisting motion, but there's also a rolling motion that's happening too, which is beautiful. That's like something
Yes.
that I teach for the animation. If you go back and look at the last little clip where they're walking, if you
This
dead
one right
center
here.
looking forward, yeah, but look at the hips like rolling
Yep.
back and forth.
So I'll go ahead and play it.
Yeah. I mean, just focus on one and you can see there's actually some tweakiness to it too. It's interesting how it's like a little oscillation going on.
Yes.
But
Yes.
it's really beautiful to see how they are, how the hips are now moving so much more naturally than they used to be.
Yeah.
Yeah.
I agree. It definitely looks a lot better. And I'm trying to think if there's anything else that I had brought. Okay. So yeah, this is something else. Is that when I saw this, I immediately was reminded of that.
Right.
And at the time, I didn't understand why he was so thrilled.
Right.
And now from that tweet, we see, the reason is because they finally got, the end to end from the manipulation of the of picking up what a human has taught as opposed to something that's been hard coded.
Well, it even goes beyond that, because look at what the text underneath it is. You've got images to joint angles.
Joint angles, exactly.
Insanely, like we're looking at a two-dimensional bunch of pixels.
Yep.
To figuring out where the hell everything is.
That's what full self-driving is. Full self-driving is images to pedal application and steering wheel. Right. Except rather than you just have like one wheel and accelerate, decelerate, you have a lot more joints that you have to deal with. So
no, I mean this is just...
now I'm putting myself. So we got, what is it, like a total of 48? I'm trying to remember. Put the figures in there.
Yes.
So yeah, that's a lot more than just like one steering wheel. Right. To be able to make that transformation. And yeah, I mean, you can see that's a spontaneous reaction there. It's like, oh yeah, finally. And and now we have something to show tomorrow.
Well, and I have a feeling that here, let me stop your sharing quick. I have a feeling that probably what we don't see is about 100 or 1,000 videos of the thing going like this, falling over, and which
it's like whenever you work in the project, you have all that and you're suffering, and then suddenly when you get it, that's why the excitement it's there. And now what we're talking about. Yeah,
we should not underestimate. I just want to hit on this again for people who might not. They might be like, "What the hell? I can pick up an object." It's in order to do this. There is the transfer, and yes, the front end of it is pretty much like full self-driving. It's like figure out the world, figure out the three-dimensional space from images, but then it has to then figure out every single joint angle in the entire body and how they interact with each other and how firmly to grasp the object and all of those kinds of things. That's just crazy.
Exactly. So the first thing, you have to identify what it is. So you're going to go there, and then you got to kind of plan how you're going to go there. You get an idea roughly what the trajectory is.
Right.
As you implement that trajectory along the way, you're going to see, are you starting to deviate from the path, and why are you deviating? Is it because loads are different or something else? That's something that Robert Plater talked a little bit about in Lex's interview, that the idea, like when you do a flip or something like that, in your head, you know exactly what you need to do, and you jump off and you launch yourself. And when you're up there, you're beginning to realize, oh, it's not going exactly the way when I'm close, but I have the ability to mid-course correct. And sometimes that mid-course correct is like when you kick your legs out, because you can change the inertia properties of your body, right? Which changes your angular rotation rate. That's all you've got, so you get a little bit of room to play with it. And that's the same thing that's kind of going on, is that you're trying to figure out, what are my limits and capabilities? What can I do? I start to execute that. And as I execute it, I begin to realize there's some deviation, and then I need to stop it. And especially if there's something unexpected, like I'm moving my hand to something and suddenly I feel something. And what do? Do I keep punching right on through, or do I instantly stop?
Right.
And that's what they were showing with the force control, the torque control. So all this stuff is coming together and finally working. And now what we're seeing is we're going to see an S curve here.
Right.
So it seems I thought they were a little bit further ahead than they were at this point, because we had all sorts of expectations of seeing what Optimus was doing last summer.
Right.
But it looks like they had some things together, and now it's a total rewrite. So they've thrown that out. And so we're starting from scratch, just like going from version 10 to version 11. The idea is that they want to have all the neural networks. So now they definitely got themselves to a local maximum, and it wasn't a very high local maximum because everything was handcrafted heuristic code.
Yes.
Now that they have this, they're just going to, it's going to be something like that. We're going to, and Elon talks about like, it's going to be like a wall.
Right.
It's almost going to look like that once you have that capability, the rate that you'll be able to go will be because it's going to now be self-learning. You don't have to have that many people in the loop constantly telling it. It just starts identifying objects and you get that flywheel, which is just going to take off.
Yeah, exactly. Yeah, it's incredibly exciting to see that. I think everybody, the problem is that you see the videos of Boston Dynamics with Atlas, doing backflips and stuff, but it's like, but this is pretty huge because Boston Dynamics is backflips, not to take anything away from them, but that is mapped out in simulation exactly.
Right.
It's all pre-programmed, and it does adjust. It'll adjust as it goes, and it auto balances and stuff.
Which it has to. Yep.
Is amazing. But this is a whole different ball game. This is like, there's an object over there, go pick it up. I'm not telling you how to do it or anything. Now I know Boston Dynamics is working that direction too. So again, there's room in the world for all of these different robots. It's not like
and there's others. And if you remember yesterday, before we saw this, we were already talking about, we have to do an episode on Sanctuary and the Phoenix robot, which was announced yesterday, which may have been like good or bad timing on their part, because that's an interesting robot that we're going to have to look at and what the differences are. But that's going to now be kind of pushed back a little bit. And this is our hot take, right, John?
Yeah, exactly. Well,
don't worry. There's a 3-hour video coming out of this somewhere.
I think it's important to understand that, like, what we're looking at is a convergence of technology right now. So it's not just Tesla, but Tesla, what they have, the advantage they have is they have a very big focus, and that is to make a practical robot that does practical things, not worry about these other things, and they have the manufacturing capacity. So that once they can get the software up to speed, again, I think prototypes are hard, production is easy. I think we're in this weird sort of inverted world for Tesla. Not true for anybody else. I think production is going to be exceptionally difficult for all the other companies. But for Tesla, that's going to be their wheelhouse. They're like, we can do this.
Yeah, they should be able to crank them out. And I'm seeing there are a lot of humanoid robot companies or bipedal robot companies that seem to have been operating in stealth mode. So Sanctuary AI, it's been around since 2018. They've got their 6th generation coming, but it's like kind of the first time that everyone's really heard about it because they probably want to keep it that way.
Yeah.
And then, of course, there's Agility Robotics. It's the same thing. They've been around a while. They've solved it at Boston Dynamics. We know Figure was announced a couple of months ago. We haven't, heard much more about that, but what it means is there's excitement out there for this idea. Yeah. It's not that Elon's crazy, because if I look at the calendar, I think 2018 definitely predates the announcement for Teslabot. So a lot of people have been thinking about it. Of course, what Boston Dynamics is doing way before that. But let's say it's gone from the Boston Dynamics robot was more of a DARPA defense kind of thing. Yes. Looking for really niche applications. Right. A lot of people saying that, no, we want a general purpose robot, and everyone just like is going down that. And the whole idea is that we want one that's going to work, in the house, around the house, in the factory, in the store, everything else. So it's not Elon's fantasy. It's just everyone wants to do it. They've all been working on it. And it looks like the Teslabot team has grown a lot. And I think it's people that have been working at some of these other research areas are coming on board now. Right. So they've kind of cut their teeth on something else, and they're looking at this and saying, yep, that's the way of the future. We want to be part of that.
Yeah, it's an incredibly exciting time to be in mobile robots. That's for sure. So here's the wrap up question for you. How much would you pay for this right now? Like if Elon said, we'll sell these robots, how much would you pay for it?
Well, let's see. My Tesla shares haven't been doing that well lately. So,
all right. I mean, in a fantasy world where you had money, how much is it worth? Okay. How much is it worth?
How much is How much is it worth? It sort of depends. If it's something around the house, most people would be willing to pay probably somewhere between 10 and 20.
Okay.
They would see that kind of utility around the house. Right. If you're looking more of a commercial setting, people would be definitely looking at 50 to 100. Of course, we talked about that. They're not going to sell these things. It's going to be more or less robot as a service.
Yep.
And, FSD right now, 200 is what they're looking at for months. So a lot of people would say, like, just having a car be able to drive me. But if you look at, how much does it cost you to cut your grass, through the year?
Right.
Or especially if you hire someone, and if you hire someone to fertilize your lawn. So, like, look at those kind of services. And then, if you're having anyone come in the house to do cleaning or any sort of maintenance around there, you start adding those things up and you begin to realize, wow, that's what my yearly cost is.
Right.
So the question is, would you be willing to pay that to a bot, or would you be willing to say one-time lump sum? Wow, I'm spending a lot of money here, that it's worth $10,000 or $15,000 for an upfront charge, and then never have to worry about it again.
Yeah.
To say nothing about like all the other things that it could do that you never wanted to pay for before because you really couldn't afford it.
Right. Right. Yeah, I guess that, and of course, Randy Kirk is all about the factory use of it. And for that, I think that has a whole different equation, because if you get
the equation is very different
use out of the robot, then it's like whatever it costs, almost within reason. I think $100,000 or $1,000 a month or 10, whatever that cost is, however it's structured, it would be worth it because it would be so valuable.
Yeah. Yeah. Because again, I mean, it's like, if you're lucky, you can hire a lawn service for like $25 a cut.
Right.
So you're looking easily $100 a month. And depending upon where you live, that's, for 12 months, or it's, for 8 months or whatever.
Yeah.
And then, of course, where I am up north in Michigan, when I don't have to cut the grass, I got to pay the guy to plow the driveway.
Exactly.
There's always the other thing. So no matter what, it's like, you're at a minimum, you're paying that. And then there's like, and that's a small yard. I mean, most people say $25, no, it's more like $35, $50 or something like that. So quickly you're seeing a lot of these services add up. And by the end of the year, you're realizing, oh, wow, I spent a couple grand on that and a couple grand on this. And it's like, oh, yeah, 10,000 seems like a bargain.
Hey, speaking of snow, I was talking to somebody yesterday. We were looking at the Cybertruck out in front that was put out there. And he was like, this thing is going to make the best snowplow. He's like, it's got so much weight. It's just gonna.
You notice it was very interesting. They didn't want anyone to get very close.
No, it sucked.
There's something that is a secret that you can't notice until you like either get into it very close. Now, down at Corpus Christi, a lot of people were very close. I'm kind of wondering when they went down there if they were hiding something, because the wheels that you saw in Corpus Christi were a little bit different, at least the hubs.
Right.
And I was wondering if there's something else, or if they're afraid that some people may have noticed something in Corpus Christi. Now they want to go back and check it out, or what it is. But I was like, they could have let you get a little bit closer than that, right? So
it was it was unfortunate. Apparently, so there's a big they've redone the whole entrance and everything. And Joe Tegmeyer said that it's going to look like the with the reflection of the steel beams in the window, it's going to look like the Plaid logo, which is going to be super cool.
Wow.
It's really cool. He showed me a picture of it, and I was like, it already basically looks like that. But anyway, they had to crane the Cybertruck down onto that concrete pad because it's off the ground, like, and they didn't want to drive it up on there because I think they
drive it up there. Okay. They didn't have a ramp to drive it up on, huh?
Well, and I just don't think they wanted to drive it. They were concerned about the load bearingness. I don't know what they're going to use that big pad for, but anyway.
Okay.
So that was an interesting little factor. And here's something that I heard from somebody who says that they know. And that is, I was like, how do you open the door on the Cybertruck? Because I was looking at it without the handles. So it will probably auto present when you bring your phone up to it, right? As you walk towards it, it'll pop open. But if it's unlocked and you don't have your phone, there's a little thing right under the side B-pillar cameras that you can swipe your finger down and it'll pop open. So it's a little touch.
Oh, okay. That would make sense. Yeah. I assume that that would make sense to be there. To me, it looks like it probably is going to be amphibious.
Oh, you think so? It does look pretty sealed.
Oh, at this point. There's like very few places for water intrusion, like into the body itself. So, and then if you start to calculate how deep the Cybertruck would actually be, Dots already did that calculation. I did the same calculation as well, is that even under maximum load, so like unloaded, it's going to be about 10 inches. And probably when you put the full load in there, you're looking at maybe 14, 15 inches, which actually doesn't come up very high on there.
No.
And then when the door was open, Ellie got a pretty good image when Drew was like opening and closing the door that you kind of look at it and you can see the seal that's around there. It's designed to kind of go in there.
So it does have a gasket seal. That's cool.
It's definitely going to seal. And of course, the whole idea is that when you get the hydrostatic pressure coming on the door, it's just going to make it better.
Yeah.
So a lot of things right there. It's like, yep, there's no water intrusion getting into the cab. It's designed to be able to be in the water for a certain period of time. Stability is going to be a question, but the problem with both cars is that the weight is in the front, so they float. They're a boat for a short period of time until they're not. And usually it's like the front end goes down, but because the mass is in the middle, the Cybertruck probably will be pretty stable.
Yeah.
And it's just a question of if you have the air suspension and you're able to move the wheels up and down, can use that as a kind of trim to get it to where you want to go.
Right.
And then we can do a whole episode on what the propulsion is going to be like for that thing. There's a lot of different ideas out there.
Right.
And it's not clear. And there's something about the wheels. There's definitely something about the wheels.
And maybe doing something like rotating them in and then spinning them, they'll give a little bit of motive force going forward or something. But
my overall feeling is you don't necessarily have to do that.
Okay.
So you can have something like the turbine hub, which is sucking water in. And you can say, well, that's not going to do anything, Scott. The water's just going to come and hit itself. Yeah, well, you just duct it.
Right.
So if you do something with the wheel housing, but I couldn't see it in the wheel housing, it looks kind of normal. But if you redesign the wheel housing in such a way that the water comes in and then you channel it and then try to bring it down underneath, then you would have a way of being able to do it. So it doesn't matter that the water's coming in this way. All that matters is that you can redirect both of them. And of course, you could do it with the wheels this way. But the same problem is it's like you do this with the wheels. Where is the flow going into? It's like, smashing into the wheelhouse, doing absolutely nothing for you. So you'd want to come up with some sort of flow for that. And then, the other thing is that they've got a pretty big air cylinder there that is going to be used for the suspension, but it could be used for other things. And I'm thinking, I wonder if they've got some bladders around there or other things that you could potentially inflate or de-inflate. I did not see, it's hard to see if you look at the close-up pictures that I saw of the hubs. I did not see the inflation stem. Now, maybe it's behind it but it's not Elon. It's like, what a hubcap was? A hubcap was an extra piece of equipment that you had to put onto your hubs.
Yes.
That you took off that was more or less just kind of cosmetic, but was an extra part. And then eventually we get down to the point, it's like, forget it. You just actually make the hub itself and you don't have anything else you put on there. Yeah. So it looks like some sort of cover that maybe they're putting over it, but that goes completely against the Tesla philosophy of the best part is no part. Why are you going to introduce a hubcap?
Right.
It must be functional. It's got to have some sort of function.
Okay.
And I don't know if it pops away and then in there you see the stem, or is it auto-inflating? So I'm kind of wondering that you might be able to control.
I see what you're saying. So you think you could actually inflate the tires using the pressure?
Yeah, the technology exists. It's out there. Some luxury vehicles do it. Buses are able to do it. And with that, you might have some sort of bladder control,
Right.
And I know men over 65, when you say something like that, they're thinking of different, but being able to change that, you'd get some sort of ballast, you'd be able to move those things around, or you have some additional things with the air coming in. Why not? Why not do something like that? And the other thing is that the biggest complaints that we have in the maintenance in our Teslas is that, and I had this like last week, I had low washer fluid.
Yes.
And every now and then you have to top off your tires with a little bit of extra air. And so now they can get rid of one of those maintenance items that you just go ahead and it automatically does it. Plus, you will be able to change the ideal tire pressure for the conditions.
Right.
And that means mileage gets a lot better, off-road handling, everything else. So there's a lot of things that you potentially do there.
Because, that's one of the things that like Jeep owners have to do if they go off-roading is they have to like stop at the edge of the road and like deflate the tires a little bit.
And the other thing is that if you've got some hydraulics or let's say some pneumatics going on through there, you can do a lot of other things with pneumatics besides inflating a tire. Yeah. So you can make things like pop out all of a sudden, it's like all of a sudden something goes, you're there, you not have to have a servo or something like that, or maybe able to do other things. So I think there's something hidden behind those hubcaps.
Oh, okay. All right.
Yeah.
I'm thinking the old the Mississippi River paddle wheel boats. They just pop out a little paddle wheel and
Well, that won't quite work for a couple of reasons, because in order for the paddle wheel to work, you have to have only the bottom part underneath.
Yeah, exactly.
The whole
That's
thing
the
is
big problem.
there.
It wouldn't
like,
really work with that. But
yeah, you basically literally just spinning, in one place.
It would be cool.
So,
it would turn up a lot of water.
But you could get it to work if you somehow did it the way a helicopter does, because a helicopter has a complicated hub that is constantly changing the pitch of it. Because in theory, the helicopter should not be able to go forward. It should just be able to go up and down. And the way you're able to do it is you've changed the pitch of that.
Right.
So if you had something like a paddle wheel was on there, but you were able to change the pitch of the wheels of those paddles you went around, you might be able to get it work like a paddle wheel.
Right. Yeah. No, what a crazy thing that we're talking about an amphibious.
Yeah. Exactly. We're going completely off script here. I thought we'd be talking about Optimus. But
hey, it's fine. I just love it. I think it's just anyway, and it's going to be, and it'll drive you there too. So maybe eventually we can get full self-driving, full self-robotics, and full self-boating. So you can actually put it in the water and it will navigate you across the channel to where you have to go. All right, Scott, thank you so much. I know you have another thing that you have to go to right away, so I will let you go. Everybody, be sure you follow Scott on Twitter. I'll put the links and all that stuff in the description. Like and subscribe, all of that good stuff. And I will talk to y'all later. Bye-bye.
Okay, bye.